Okay, everyone, welcome to my channel. Today we are going to be looking at the C programming language. C programming is it's a language that exists between both the high level and the lower level. It can operate at the lower level and the higher level, whichever one. Lower level in the sense that it can communicate with the bare metals of your machine and the ones and zeros of a machine, and as in directly with your machine. And also it can also operate at a much more higher level. It has libraries and that contains inbuilt functions and all that. Now, in working with the C programming language, it's unlike Python, where you have to install the language itself. In C or C++, whichever one, you are not actually installing the language. Rather, you are installing a tiny bit of software called the compiler. A compiler is a software now that enables you to compile your code. It enables you to actually convert your code into an executable file that will only be understood by your computer, by the machine. It cannot be read by the human being. Yeah, so first thing first, I'm currently working on the Linux box. So if you're working on the Macintosh, yeah, you are most likely going to be following me. But if you are using the Windows machine, then you have to install a software called Cygwin. Yeah, I think so. Either Cygwin or Menguin. Yeah, it gives you a POSIX-like environment which will enable you to compile your C code like you are in a Linux environment. Yes, you can issue Linux command. You can do a lot of things within that particular environment. Or if you are a little bit phobia about working the command line, you can install code blocks. Code blocks is like an IDE. By IDE, I mean it's an integrated device environment where you can run your code. When you download code blocks from the internet and you install it the way you install your normal software, it comes along with an inbuilt compiler. Yeah, it has GCC. Yeah, and that's the same compiler that we'll be using in this video. Now, GCC is an open source software. By open source, I mean it's a software that is free to use and is free for developers around the world to actually work on the on the developer's code and edit it, tweak it the way you like, probably optimize it and contribute to the open source community. Now, before we install the GCC in our machine, we'll have to update our software repositories and upgrade the version of the software that we have in our system. Now, the reason for updating and upgrading is due to the fact that softwares in our Linux machine, they depend on each other. So these things now, they are referred to as dependencies. These are packages that enables our software to work. For example, now, if you have something like Visual Code in your system, VS Code now in your system, and you want to update your system, assuming the latest version of VS Code now is 3.2, when you update your software package index, it will update your software from 3.0, probably your current version is 3.0, from 3.0 to 3.2. Yeah. So then later on, you can now upgrade it by downloading the software that will make it that particular 3.2. It will download the patches for you. Now we're going to update our software using sudo. Now, what's sudo? Sudo is a command in Linux that enables you to it gives you an administrative privilege to issue a certain command. I cannot just go ahead to say apt get update. It will not allow me because I am not an administrator. But with the help of this my sudo command, yes, I can do it. At least I'll be a root user, an admin temporarily for the purpose of updating my software or performing whatever command that I'm going to perform that requires administrative privileges. So sudo apt get update. This is the command to update our software repo. Now, apt, what's apt? apt is the package manager. If you are using what do they call it again? Macintosh OS. Now, if you are using Mac, you can use its own package manager called Brew. Yes, Brew is a package manager for Mac that enables you to manage your softwares, either to install updates or install or whatever thing that you want to do with it. So I'll be updating my software repo now. I'll hit my enter key. It will ask me for a password, definitely, because I'm using sudo. It wants to make sure that I have administrative privileges to perform this particular command. And before you perform this command, make sure that you are connected to the internet. Very compulsory. So I'll go ahead and type in my passcode and see what happens. Yeah, it's currently working. Now it's not quite long I did mine, so I don't think it's gonna waste much time. If it's been a while you did yours, then this particular process might take a little time because it needs to update all the softwares in your machine. So because it's not quite long I did mine, most of them are quite up to date. So it will just have to download certain missing components, and that's it. So it's currently updating it from these particular archives. All these links you are seeing, they are inside a particular file called the source list. The source list, that contains links to various servers, Ubuntu servers now around the world that assist the package manager to update your packages now. So after issuing that update command, I will go ahead to say sudo apt get upgrade, right? So what am I doing? I'm currently upgrading the software. Look at it. It said it needs to get 750 kilobytes of 14 MB of archives from the internet, and after this operation 0 bytes of additional disk space will be used. So this is the software that it needs to download. This is the update that it needs to download so that it can upgrade the current version of my software to the recent version. So the size of the updates they added to the older ones is 750 kilobytes in size altogether, in summary. So I will enter my yes, and it goes. So this is going to take a little time. It's going to take a little time, although not too much because it's just 750 kilobytes. Now, if you are doing this for the very first time, it's going to take some time because it's going to be larger than 750 kilobytes because it will definitely do every single bit of software in your Ubuntu machine or whatever Linux distro that you are doing. Now, if you are using other Linux distro, you have to check your documentation so that you know the exact command to issue. But as far as Ubuntu or Debian-based software is concerned, they normally use apt as their package manager. So we are going to be writing our first C code. Oh, before we write our first C code, we have to install our compiler. Now, I already have my compiler installed. The name of the compiler is sudo apt get install GCC. Is GCC. That's the name of the compiler. Is GCC. Now, there are two major open source. There are two major types of open source compilers. Now we have GCC and we have Clang. GCC or Clang. Now, a lot of persons prefer Clang to GCC because Clang kind of like it gives a better error information when you have some errors in your code. So you can install Clang, but it's the same thing. Whichever switch or whatever options I'm using in terms of trying to compile my code is the same thing. They will work the same way. So install GCC, and I'll hit my enter key, and it will ask me if I want to get the same thing as the update command. It will ask me if I want to get this particular archives. Currently, I think everything is up to date. That's why you are seeing 0 bytes there. So if I press Y, it goes, and I don't think it will do anything because this is 0 bytes. Yeah, I thought as much. So it came back to my command line now, to my terminal. It never did anything because there's nothing actually to upgrade there. Now we're going to be running our first C code. Vim. Now I'm using Vim because is what I prefer. You can use any text editor. If you are a Windows user and you are using code blocks now, if you are using code blocks, then code blocks is an ID. Definitely you will see an environment for you to type in your code, and for you to run your code, there's actually a play button here, a run button for you to click and just run it, and you get your output. But I'm using Vim. Now it's my personal preference. You can use any text editor that you want to use. You can use Nano, you can use Gedit, you can use Notepad++, you can use VS, whichever code editor you feel comfortable with. You can go ahead to use it. But the bottom line is that try to use the same compiler as I'm using, or you can use Clang, whichever one. It will always work. GCC. What am I going to call our first program now? We're going to call it let's say first.c. Now I'm using the .c because I want to write a C code. If I was writing the C++ code, it's going to be .cpp. If it's a Java code, it's going to be .java. So I'm going to write my first C code now. Include stdio.h integer main void. Okay, now if you look at this particular line of code here, it is very, very important. The reason why it's important is because of the code I want to write here now. There's a particular function, there's a particular code I have to write here. This code I want to write here is found inside this particular file. I told you that. Now, normally when you see a name here and you see a dot and you see another letter here, either 1, 2, 3, or 4, you know that after that particular dot, after that full stop, the other ones represent the extension of the file. Now, this is the file name now, and this is the extension. .h means what? It's an header file. That is why it's at the top of our code. It's at the head of our code. So stdio means standard input and output. Now, the code I want to write on this place is an output file. I want to print out something. That is why I am using standard input and output. If I don't include my stdio.h, whatever thing I want to write here will not work. This C will look for it. It will tell me that it doesn't know it. It will tell me that this thing I'm writing here is strange to it. But because I have included this particular guy here, then everything I'm going to write, anything I'm going to write here, I must make sure that it is defined inside this place. And this hashtag you are seeing, this pound sign you are seeing, include, it is meant for the preprocessor. For this preprocessor in the compiler to actually preprocess first before it comes to my code. So whatever any statement in your code that starts with a pound sign normally runs first before the main code that you are writing runs. So I will issue something like printf. What's printf? Printf is to print out whatever thing that you want to print out as far as C is concerned. All right, printf programming is an intense form. Then that's it. Now, I'm going to come back to this code. But have it in mind that every code line in C ends with a semicolon. It ends with a semicolon. Every code line ends with a semicolon. So if I write a statement without the semicolon, it will flag it as an error. So I will have to come and fix the bug. Now, when you hear me talking about bugs are errors in your code. It's as simple as that. So I will say return 0. Why am I saying return 0? It's become very clear to us much more later in our subsequent videos. Now, but just to give you a heads up, this 0 is coming from the fact that I wrote an int. Int means what? It means integer. Integer is a whole number. So when I say return 0, because there's an int, if I had written something, there are some C code that you'll see. You'll get to see something like void. Void means nothing is there, right? Nothing. So it means that I'll have to remove this, my return statement. Though there will be no point returning 0 because right here and there it is void I am seeing. So because I'm using an int, that is why I am using return 0. So that's it for that. Let's go and compile our code. Now, how do you compile your code? Very simple. Write the compiler. If you are using Clang, you write Clang first.c. But because I'm not using Clang, I'm using GCC. I'll write GCC first.c, and I'll hit my enter key. Because it has taken me back to my command line, it's an indication that everything ran well. If there's any error in my code, let's assume I say, let's go back to that code and do something like, let's say, okay, let me remove this semicolon there and try to compile it again. You see, it's an error. It's telling me that error expected semicolon before return. Yeah, so that's it. It means that I have a bug in my code. I have to go back there and fix it. Then after fixing it, you have to go there again and recompile. That's it. You have to go back there and recompile. Now, there's a command in Linux called ls. What's ls? ls means to list the files that is inside your current directory. I am currently inside the directory called C code, and this C code is currently inside a directory called YRX. So if I say ls, and I hit my enter key, it will list out the files and directories inside my current inside my current directory. So I have a.out here. I have a.out here, and I have first.c. What's first.c? First.c was the file we created. Then what's a.out? A.out is the file that my GCC created after compiling my first.c. It's the executable file, it's the output file. Now, we can decide to choose any file. We can decide to give it any name. But let's run that code and see what happens. A.out. So that's it. It ran well. Programming is an intense fun. But the problem is this. I'm supposed to return to my next line. There's an error here. It's not really an error actually, but it's not really readable compared to what we're going to do to that particular code now. It's not really readable in the sense that programming is an intense fun. Now, if you see my command line, on a normal ground, this line is supposed to return to the next line. This entire thing it's supposed to return to the next line, but it's still on the same line as my output. So we'll have to go back to that code and do something here. So after this fun, I'll write a /n. What is /n? /n means new line. It's an escape character. There are certain things called escape character. Escape characters are characters that you cannot manually write. For example, now I cannot write enter here. For example, I can't say enter, so that when it gets to this particular part, the enter, when it sees enter, it will go to the next line. There's really no code as such for me to actually define my enter key. So what we normally use is an escape characters now. So I will say /n now. We have escape characters for tabs, for spacebar, for making sound from your computer and all that. So because it's a new line that we're looking for, I am going to use my /n, and I will save and exit. Let's recompile again. Then I will run my code again. That's it. So it is no longer on the same line the way it is now. So because of that /n, when the code got to the end of the file, it saw the /n and it brought the cursor back to this line, and so it's actually inserted a new line into it. And there's another thing you must know about programming, whether you are writing in C or you're writing in Python or whatever thing that you are writing on. Programs reads from top to bottom and from left to right. That's how it works. It starts from the top it goes like this, it comes again, goes like this, it comes again, goes like this, it comes again, goes like that. Is how programming codes are normally read by an interpreter or a compiler. So let's go now. Our output is a.out. Now, if you are using the Windows OS, you're not going to be running it like this. Like I earlier said, there is a run button there. If you are using code blocks, there's a run button there that you have to click and it runs your code for you and all that. Now, our default file that GCC normally print creates for us is a.out. That's our default file. Now, if you want to change it to your own version, you have to use an option when compiling your code to, let's say, GCC. Okay, I'm compiling our code again. I'll put -o space. What's O? O means output. The output file. You can name it any name that you want to give it to. You can just use anything. I can use output and it will work. I can use first and it will work. I can use whatever thing I want to use. So let's say output now, and I'll hit my enter key. Yeah, it ran well. Then let's use our ls again to check the files that we have in it. Okay, we have an output file now which we created. So these are our custom output file that we want it to be, and here is the former one is created. I'll go and run my output file. Output, and that's programming is an intense fun. So that's it for that. So that is how to run your C code. Whatever program that you are running in C code, whatever thing that you are doing in C code, this is the basic way to actually run it. Unless you're not working with external libraries. Now, maybe you are trying to work with Python bindings in your C code. You're trying to work with Java bindings in your C code and all that, and using C Python or whatever thing that you're trying to do now. Then you cannot have to, then you have to use certain compilation options now while compiling it, so that to include that external library now. Libraries like PyBinding 11 and all that. Yeah, these are libraries that enables us to work with to embed Python, to bring Python functions now, Python characteristics now, functions into our C code and enable that particular C code to call those Python functions so that it can work with it. So unless maybe you are doing that and all that, then your method of compilation will be different from the basic one that we just did, which is this one, GCC, your source name, then -o, then whatever output name you want to give it. So that's it for that. So I'll encourage everyone to please subscribe, like, and share as we upload subsequent videos about computer programming, problem solving, and building of applications. Goodbye for now.